Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Performance Tuning and Optimization. Performance tuning and optimization in serverless architecture within AWS is essential for ensuring that applications are both efficient and cost-effective. AWS offers various services like AWS Lambda, AWS Fargate, and Amazon API Gateway that form the core of serverless architectures. These services allow developers to focus on writing code without worrying about provisioning and managing servers. However, maximizing the performance of these serverless applications requires a deep understanding of the underlying principles and best practices. AWS Lambda, a pivotal service in serverless architecture, allows code execution in response to events without managing servers. The performance of AWS Lambda functions can be optimized by fine-tuning several key parameters. One of the primary factors is the function memory allocation. AWS Lambda provides between 28 megabytes and 10 gigabytes of memory, and the amount of memory allocated to a function also determines the proportionate CPU and network resources it receives. Increasing memory allocation can reduce execution time for compute-intensive tasks, leading to better performance and cost savings, since AWS charges are based on the execution time. Another critical aspect is the cold start latency, which occurs when a function is invoked after a period of inactivity, requiring AWS to allocate resources and initialize the function. Techniques such as provisioned concurrency can mitigate cold start latency by keeping a specified number of function instances initialized and ready to respond. Additionally, optimizing the function code by reducing package size and minimizing external dependencies can further reduce initialization time. AWS Fargate, another serverless compute engine, allows running containers without managing the underlying infrastructure. Performance optimization in AWS Fargate involves right-sizing the task definitions by specifying appropriate CPU and memory requirements. Over-provisioning resources can lead to unnecessary costs, while under-provisioning can cause performance bottlenecks. Effective use of elastic load balancing and Amazon CloudWatch for monitoring and scaling can ensure that applications handle varying loads efficiently. Amazon API Gateway, which enables developers to create, publish, and manage APIs at any scale, plays a crucial role in serverless architectures. Performance tuning for API Gateway involves configuring caching for API responses to reduce load on backend services and improve response times. Setting appropriate cache time-to-live values based on the data's freshness requirements can significantly enhance performance. Additionally, enabling throttling and rate limiting can protect backend systems from being overwhelmed by high traffic volumes, ensuring consistent performance. Cost optimization is inherently linked to performance tuning in serverless architectures. AWS provides the AWS Cost Explorer and AWS Trusted Advisor tools to help analyze spending patterns and identify cost-saving opportunities. By examining the function execution patterns and optimizing memory settings, significant cost reductions can be achieved without sacrificing performance. Additionally, implementing logging and monitoring using Amazon CloudWatch logs and AWS X-Ray can help identify performance bottlenecks and optimize code execution, leading to better resource utilization and cost efficiency. Security considerations are also paramount when optimizing performance in serverless applications. Ensuring that functions have the least privilege access to AWS resources minimizes security risks and can improve performance by reducing the overhead associated with excessive permissions. Implementing AWS identity and access management roles and policies tailored to specific functions ensures that they have only the necessary permissions to perform their tasks, enhancing both security and performance. The choice of database and data storage solutions also impacts the performance of serverless applications. Amazon DynamoDB, a fully managed NoSQL database service, is a popular choice due to its scalability and low latency performance. Optimizing DynamoDB involves configuring the read and write capacity units appropriately and using features like DynamoDB Accelerator to reduce read latency. Additionally, designing the database schema to minimize the need for complex queries can improve performance and reduce costs. Networking considerations, such as the use of Amazon Virtual Private Cloud endpoints, can also influence performance. Placing Lambda functions inside a VPC allows them to securely access resources within the VPC, but it may introduce additional latency due to network interface initialization. Optimizing the VPC configuration, including the use of subnet placement and efficient routing, can mitigate these latencies and enhance overall performance. The use of asynchronous processing and event-driven architecture patterns can further optimize the performance of serverless applications. By decoupling components and using services like Amazon Simple Notification Service and Amazon Simple Queue Service, applications can handle high-throughput workloads more efficiently. These services enable reliable message delivery and allow functions to process messages at their own pace, reducing the risk of performance bottlenecks and improving scalability. In summary, performance tuning and optimization in AWS serverless architecture involves a multifaceted approach, including memory and resource allocation, cold start mitigation, effective use of caching and throttling, cost and security optimization, and choosing the right database and networking configurations. By leveraging AWS's robust suite of tools and services and adhering to best practices, developers can ensure that their serverless applications are both performant and cost-efficient. This comprehensive strategy not only enhances the user experience, but also aligns with organizational goals of scalability, reliability, and security. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.